So last time we solved a three-variable system of equations using elimination. Today we'll do the same thing with substitution. Substitution is going to be where we solve for one variable in one of the three equations, and then substitute that variable's equivalent value into the other two equations. So here we could solve for z in the top equation, we could solve for y in the middle equation, or we could solve for x in the bottom equation. I've chosen to solve for x in the bottom equation, but any of those three will work. So the first thing we do is we move our equation somewhere we can work on it efficiently. So I'm just going to copy it over here. And I'm going to multiply everything by -1 so that x is positive, because I want to leave x on the left side of the equation. If I add 5y and 3z to both sides, I'll get a value for x in terms of y and z. So x is equal, those crossed out here, those crossed out here, to 5y plus 3z minus 1. So that's going to be our value for x. We'll bring x over here. This was step 1. Isolate a variable. So use substitution to obtain two variable equations. So here's what I mean by that. We're going to take what we just found, x is equal to 5y plus 3z minus 1. And we're going to note we already used this bottom equation here. So that's out. We're not going to use that one. Already taken care of. So we're going to use the top two. I'm going to take 2, instead of x in this equation here, it's going to be 2 times 5y plus 3z minus 1 plus 3y minus z equals 7. So I've rewritten the equation, the very top equation here, but instead of using x, I've replaced it with the value for x that we found here. This is x. So now I'm going to distribute here. 2 times 5 is 10y, plus 6z minus 2, plus 3y minus z equals 7. We can combine like terms. So we do have a few like terms. Here we have 10y and 3y, and we have 6z and negative z. So it's going to be 13y plus 5z minus 2 equals 7. Move the 2 to the right side. 13y plus 5z is equal to 9. For now, we're going to leave that there. We're still in step 2, but we've only found one of our two variable equations. So that's the first of our two variable equations. Now we've used this equation. So the last equation that we want to use is that middle equation. I'm going to copy it, move it down so that we can work with it. We need to replace x with this. So everywhere that we see x, we are going to write 5y plus 3z minus 1. So now we can once again distribute. That's 20y plus 12z minus 4 minus y plus 2z equals 10. So here we do have our usual like term. Oops, wrong one. So we've got some z-like terms and some y-like terms. 20y minus y is 19y. 12z plus 2 is 14z. Minus 4 equals 10. Add the 4 to both sides. 19y plus 14z is equal to 14. Going to bring them over here for step 3. Because step 3 is to solve the system of two variable equations. Now, up until now, there have been no fractions. But here, there's not going to be a way to avoid them. So when I bring this down and I solve it, I'm going to solve for 5z by subtracting 13y. So 5z is equal to 9 minus 13y. I'm going to divide everything by 5. And we get that z is equal to 9/5 minus 13y over 5. So just a way to make that easy to find in a moment. Because that's important, we're going to have to reuse it. Excuse me. We're also going to plug that value in to the lower equation, because we could think of 14 as 14 over 1 and then distribute that fraction. This means we're only multiplying numerator by numerator and denominator by denominator. So we get 19y plus 14 times 9. So we say, what is 4 times 9? Well, 4 times 9 is 36. What is 9 times 1? Well, that'd be 9. But 9 plus 3 would be 12. So 19 times, or I'm sorry, 14 times 9 would give us 126. In the denominator, we have 1 times 5, or just 5. We have a positive times a negative, so we get a negative. 14 times 13 is 182. And again, you can work that out in various ways. If you're not using a calculator, the easiest way to do this, if you don't have it memorized, is just to say 3 times 4 is 12, 3 times 1 is 3, plus 1 is 4, 4, 1, add them together. Boom. Doesn't take you long. Depending on your comfort level, you could almost do it mentally. All right, 1 times 5 is again 5, and this time we have a y. This is all equal to 14. The easiest way to handle this is to do a side calculation and say, what is 19 minus 182 over 5? We're just looking at the coefficients. We know it will be y when we put it back into the equation. So we can treat that as 19 over 1. We can multiply it by 5 over 5. 5 times 9 is 45. 5 times 1 is 5, plus 4 is 95. So then we just take 182 minus 95, and we get 87. So negative 87 fifths. So that's going to be our y value, negative 87 over 5y plus 126 fifths is equal to 14. But now we can go about solving as we normally would. I'm going to subtract 126 fifths from both sides. And again, this brings up a fraction problem. We're going to subtract. This part, these still cancel out. So far, so good. And here's where fractions can be helpful. So we get to this step. We have negative 87 fifths y is equal to negative 56 fifths. When we multiply by a fraction, or divide by a fraction, we multiply by the reciprocal. So I'm going to multiply by negative 5 over 87. That's the same as dividing. I do it to both sides. Here, we know it's going to cancel out, and it does. And a negative times a negative is a positive, so y is equal to, on the right side, we still have a negative times a negative, so our answer will be positive. We also have a 5 and a 5, which cancel out, leaving us with a 1 and a 1. 56 times 1 is 56. 1 times 87 is 87. So while it may feel intimidating, it's not any harder than problems you've done before with multiplication. You multiplied numerator by numerator, denominator by denominator. So we're going to bring this down here because we didn't have enough space with the way I was working it. So z is equal to 9/5 minus 13/5 y. All right, and y was 56 over 87. So now we need to find what this multiplies out to. So we've got 13 times 56 in the numerator, which is 728. And we have 5 times 87 in the denominator, which is 435. To combine these, 9/5 needs to be multiplied by 87 over 87. So 9 times 87 is 783. So once again, we're going to circle that. That will be part of our final answer. And in this case, I should make it very clear, that's just this one. 11 over 87. So now we're in the very final step. We're going to go back up to our original value that we solved x for. And we're just going to copy that and bring it down. We'll bring that down here. And we're going to plug in the two values that we have for y and z. X is equal to 5 times 56 over 87 plus 3 times 11 over 87 minus 1. Now, right now, before I do anything else, I know that this needs to be converted to 87ths because this is an 87th and this is an 87th. So I'm going to do that real quick along with this first step. So this is going to become 1 over 1 times 87 over 87. 5 times 56 will give me 280 over 87 plus 33, 3 times 11, over 87 minus 87 over 87. So x will be equal to, it'll become 313 over 87 minus 87 over 87. And I was adding 280 plus 33 to get that 313. Now, we subtract 87 from 313, so x becomes 226 over 87. This is the very last piece of our solution. So our ordered pair solution is 226 over 87, 56 over 87, and 11 over 87. And that's it. We can check that in the original, and you will find that that works in all three equations. So quick summary. Step 1, we isolated a variable of our choice. We picked x. Step 2, we used substitution in two different equations to obtain two variable equations. So we did it to the top equation and got this. We did it to the middle equation and got this. We then moved those here. And step 3 was to solve this two variable system. So we worked through that using substitution. We solved for z. plugged in z, worked it out to get y. That was our first solution. Came back to here, came down here, solved for z, and now we have now we have y and z. We went back to step 1 and plugged it in for our final answer.